And as you can see, I have marked the ones that can work inside an Octane material with a green check. The ones that cannot work inside an Octane material have been marked with a red X. As you can see, the effects group is absolutely ignored by the engine for understandable reasons. Recently, the color shader from the MoGraph group has been integrated in Octane, which has been a huge improvement and a huge advantage for anyone using Octane. The Sketch and Tune module is completely ignored, and all shaders on the surfaces are successfully recognized and used by Octane Render. Polygon hair is ignored as well. In the next minutes, I'll take some time to explore the most important shaders, both from the Octane shaders group and the built-in Cinema 4D shaders, and take a look at how they work together. The first Octane material shader I want to talk about is called Image Texture, and if you remember from the previous slide, image textures use image files to create the texture. In this example, I want to assign a concrete material to my surface. So I will create new diffuse material and apply it to the surface. Select the material and check the diffuse channel. As we said, we don't want to use plain color, but we want to work with textures. So under texture, Octane for Cinema 4D, select Image Texture. Click the node once to enter its properties. First, we need to assign the external image. Select any file you wish from your computer and press Enter. As soon as applied, you can see the image renders in the live viewer. Below are a few additional parameters to control the look of the applied image. First, we have power, which is the brightness of the material. We can go down to 0 or to values way beyond 1. Alternatively, you can use an external image or shader to control the mapping of the brightness. Gamma is self-explanatory, I assume. Invert will invert the RGB colors. We'll skip border mode just for now, and let's take a look at type. This is your chance to communicate with Octane Render. This field actually sets the type of image you're giving the render engine. So in situations where the channel the image is applied to only can recognize grayscale data, like the bump, roughness, or specular channels, then the image type needs to be set to float. In situations where we're using full color data, like in this example, I can stay with normal. And the reason why this is important is the following. Take a look at the used, free and total VRAM line of text down here. We can see that currently, with the texture type set to normal, the used VRAM is 42 megabytes. Now, if I set the type to float, two things will happen. First, our image will be forced to render as a grayscale image, and second, the used VRAM will drop down to only 16 megabytes. So pay attention to the requirements of the channel you are loading the image into, and always set the correct image type. If you are loading images with an alpha channel, you need to select the alpha type. Next, let's take a look at UV transform and projection. These are actually two additional nodes which we talked about in the previous example down here: texture projection and transform. These provide methods of transforming and reprojecting shaders or textures. So how is this useful? Well, let's say we wish to move this texture in X and Z and probably rotate it and maybe scale it up or whatever. The traditional Cinema 4D workflow would suggest that you need to select the texture tag and used some of the parameters down here, either offset, length, tiles or repetitions. So let's select offset U and adjust the parameter just a bit. And as you can see, while the editor reacts, the live viewer doesn't render the updates. To see the effect of this parameter, I need to resend the scene every time I make a change. While this works great, this is not the optimal solution. Let's take a look at the Octane way of doing this very same procedure. Select the material, click Image Texture, and let's apply UV Transform, which will apply the transform shader to the image texture. Immediately you can recognize three major groups of parameters. We have rotation in X, Y and Z, scale